By the end of this module, you should be able to define water source heat pump, identify the main components of water source heat pump, and explain the unique components of water source heat pump.
Water source heat pumps are highly efficient heating and cooling systems that utilize the principles of refrigeration to transfer heat between a water source, such as a well, lake, or cooling tower, and the indoor space. These systems circulate water through a closed-loop system, providing both heating and cooling. WSHPs are commonly used in commercial and residential applications where access to a water source is available. A water source heat pump is a complex system consisting of several key components working together to transfer heat between indoor and outdoor environments. Let's explore these components. Evaporator, condenser, compressor, expansion valve, piping and tubing, sensors and control systems, and oil separator and accumulator. Water source heat pumps exhibit several key characteristics that make them a desirable choice for heating and cooling. High efficiency, variable capacity, quiet operation, zoning capability, and versatility. High efficiency. Water source heat pumps are renowned for their high energy efficiency, delivering more heating or cooling energy than the electrical energy they consume. Variable capacity. Many water source heat pumps offer variable capacity capabilities, enabling precise matching of output to the heating or cooling load. Quiet operation. Water source heat pumps are typically quieter than traditional systems due to the absence of noisy outdoor condenser units. Versatility. Water source heat pumps are suitable for various applications, including space heating, cooling, and domestic hot water heating. In addition to the key components, some water source heat pumps may include unique components to enhance their functionality and efficiency. These unique components include water-to-refrigerant heat exchanger, flow control valve, and water circulation pump. The water-to-refrigerant heat exchanger is a pivotal component in a water source heat pump system. This specialized device plays a critical role in enabling efficient heat transfer between the water source and the refrigerant. During operation, it serves as the interface where the refrigerant interacts with the water, either absorbing heat from the water source during the heating mode or releasing heat to the water source during the cooling mode. This bidirectional heat exchange is central to the water source heat pump's ability to provide both heating and cooling. The flow control valve is a valuable addition to many water source heat pump systems. This component is designed to regulate and manage the flow of water from the source to the water-to-refrigerant heat exchanger. By controlling the rate at which water circulates through the system, the flow control valve plays a crucial role in maintaining optimal heat exchange. It ensures that the flow of water is carefully adjusted to match the specific requirements of water source heat pump, enhancing its overall efficiency. Moreover, the flow control valve helps prevent unnecessary water wastage and ensures that the water source heat pump operates at its peak performance, especially in variable load conditions. The water circulation pump is a key component employed in certain water source heat pump systems to ensure a consistent flow of water between the water source and the water-to-refrigerant heat exchanger. This pump's primary function is to maintain a continuous and uniform flow rate, which is essential for achieving optimal heat transfer. By effectively circulating water, the water circulation pump helps maximize the water source heat pump's efficiency. It ensures that the heat exchange process occurs smoothly and consistently, regardless of variations in the load or demand. This unique component is particularly advantageous in water source heat pump setups where maintaining a consistent flow rate is critical for performance and efficiency. Here is the list of advantages of the water source heat pumps. High energy efficiency, quiet operation, and versatility. High energy efficiency. Water source heat pumps are highly regarded for their exceptional energy efficiency. They can provide more heating or cooling energy than the electrical energy they consume, resulting in significant energy savings and reduced operating costs. Quiet operation. Water source heat pumps are known for their quiet operation, making them an excellent choice for applications where noise levels must be minimized. Unlike traditional systems with noisy outdoor condenser units, water source heat pumps operate discreetly. Versatility. Water source heat pumps offer remarkable versatility. They can be employed for a wide range of applications, including space heating, space cooling, and domestic hot water heating. This adaptability makes them suitable for various settings. Here is the list of disadvantages of the water source heat pumps. Need for a water source, installation costs, and maintenance challenges. Need for a water source. One of the key disadvantages of water source heat pumps is their requirement for a dependable water source, such as a well, lake, or cooling tower. This constraint limits their feasibility in areas where access to a suitable water source is lacking. Installation costs. The initial installation costs of water source heat pump systems can be relatively high, primarily due to the need for well drilling, water source infrastructure, and complex HVAC equipment. This may pose a financial barrier for some applications. Maintenance challenges. Water source heat pump systems may entail maintenance challenges, especially concerning water source maintenance, water quality, and potential issues related to water source contamination. Proper upkeep is essential for system longevity. In conclusion, a water source heat pump has different components, each with a specific role. So, just like a team, these furnace components work together seamlessly to ensure our homes stay toasty when we need it most.